Lesson 2, Part 2. This one says solve the system by substitution method. I just added this one, so I'm pretty sure it's not in the lecture guide. All right, on this one right here, it looks different than the other ones because in the other problems I was telling you to look for a variable that has a coefficient of 1. Well, this one doesn't have that. We don't have a coefficient of 1 on any of the variables in any of the equations here. So is there something we can do to create a variable of 1? So I'm looking at the second equation, and I see if I divide by 4 here, I'd have a 1 for the coefficient on the y. 12 is divisible by 4, but 6 isn't. We'd be creating a fraction there. So let's look at the other equation. Oh, and let me put that little tip up there. In this equation here, if I divide by 4, 2 and 6 are not divisible by 4. If I look at the 2, if I divide everything by 2, well, 4 is divisible by 2, and 6 is divisible by 2. So that's what I'm going to do. I'm going to attack the first equation, and I'm going to solve for y in that first equation. So I'm going to divide everything by 2, which gives me 2x plus y equals 3. I'm going to solve for y, so I'm going to subtract 2x from both sides, and now I have solved for y in the first equation. I can now substitute this expression for y in the second equation. So here's the second equation. I'm going to pull out the y and pop in this expression for y, the minus 2x plus 3. Now I'm going to distribute the 4. I'm going to gather up like terms right here. 6x minus 8x gives me the 2x. I'm going to subtract 12 on both sides. This is where a lot of people get stumped because they're afraid to take 12 and subtract 12. But 0 is a number. It's on the number line. You're allowed to use it. All right, if you divide both sides by -2, 0 divided by any number is 0. So I get an x of 0. I'm going to go back to this equation right here and find out what y is. So I'm going to use this equation. I'm going to put in a 0 for x. This term becomes 0, and I see that y equals 3. So my solution is 0, 3. Now to check my solution, I would plug those two, that x coordinate and y coordinate, into both of these equations and make sure I've got true statements. I'm not going to do that in the interest of time. All right. I picked this one out of my math lab because it has all these fractions. Once again, this probably is not in the lecture guide. All right, we've got to solve this system by substitution, and I want to eliminate the fractions first. We can do that. If I look at the first equation, I see divided by 5, I see divided by 5. I'm going to multiply everything in the first equation by 5. So when I do that, this 5 times 1 over 5 becomes 1. This 5 times 2 is 10. Divided by 5 is 2. Fraction eliminated. In the second equation, I see division by 8. So I'm going to multiply everything by 8. When I take 8 times 7/8, I get 7x. When I take 8 times -5, I get -40. So now I have two equations and the fractions are eliminated. Let's just focus on those two equations now. Okay, so I'm looking at the two equations and I'd really like to find a variable in either equation that has a coefficient of 1. And I see it right here. I'm going to solve for x. I'm going to subtract 2 from this equation, and I get x equals 5y minus 2. So now in the second equation, where this x is, I'm going to take out the x and substitute in this expression for x. distribute the 7 to both terms. So I get 35y minus 14 minus 40 equals 8y. I'm going to combine like terms here. Negative 14 minus 40 is negative 54. I have 8y on the left side and 35y on the right side. I told you guys when this happens, which one has the smaller coefficient. That's the one you want to get rid of. So the 8y does, I'm going to subtract 8y from both sides. What's 8y minus 8y? Yes, it gives you 0. 35y minus 8y gives me a positive 27y. I'm going to add 54 to both sides. Divide both sides by 27. I get y equals 2. Now that I know that y equals 2, I can plug that back into this equation here and solve for x. So let's plug in a 2 right there. 10 subtract 2 is 8. My x is 8, my y is 2. I would substitute those two coordinates back into both equations to check to make sure it's true. Okay? Couple more problems. Write a system of equations. This isn't going to be in your lecture guide either because I just added these. Write a system of equations modeling the given conditions, then solve the system by substitution method and find the two numbers. All right, it says the sum of two numbers is 71 and one number is 23 more than the other number. Find the numbers. When you're solving these kind of word problems, it really is the best idea to define your variables. So I'm going to say let x equal the smaller number, and I'm going to let y equal the larger number, and I know the sum of the two numbers is 71. That's my first equation. My second equation comes here. One number is 23 more than the other, so that one number has to be the bigger number. So y, which is the larger number, is, that's your equal sign, y is 23 more than x. And there's your two equations. This one is already set up for substitution. I'm going to substitute this expression for y in the first equation. Because we're not subtracting, we don't need those parentheses. Combine like terms, x plus x is 2x. Subtract 23 from both sides, divide both sides by 2. I know x is 24. Now, if I know x is 24, I can get y by plugging 24 in for x right here. And I get y is 47. And you can check your answer. Is 24 plus 47 equal to 71? Yeah. Is 47 23 more than 24? Yup. We found our two numbers. One more. Same kind of deal. Write the system of equations, then solve for the two numbers. It says the difference between two numbers is 4. The sum of the larger number and 4 times the smaller number is 29. Find the numbers. Once again, let's define our variables. Since the difference of the two numbers is 4, now let me define my variables first. This time I said let x equal the larger number and let y equal the smaller number. Now let's go back to this. The difference of two numbers is 4. Since it's positive 4, that's got to be the larger number subtract the smaller number. If this had said negative 4, it would be the smaller number subtract the larger number. Okay, so since it's positive, it's going to be the larger number subtract the smaller number equals 4. The second equation, or the second sentence says, the sum of the larger number, that's x, and 4 times the smaller number, that'd be 4 times y, is equals 29. The sum of the larger and 4 times the smaller is 29. Okay? So now I want to pick a variable that has a coefficient of 1. So I could either use this x or this x. It doesn't really matter. Looks like I chose this x. I subtracted 4y from both sides. Now I'm going to substitute this expression into x over here. Okay? So negative 4y plus 29, that's another expression for x, minus y equals 4. I don't need these parentheses here. I'm going to gather up like terms. The negative 4y minus y is negative 5y, plus 29 equals 4. I'm going to subtract 29 from both sides. Divide both sides by negative 5. I know what y is. So I'm going to take 5 and substitute it in for y over here. And when I do crunch my math, I'll find out what x is. Plug in 5 right there. Negative 4 times 5 is negative 20. Negative 20 plus 29 is 9. So my two numbers are 9 and 5. I can go back and look to make sure that it's correct. The difference of the two numbers is 4. Well, yeah, 9 subtract 5 is 4. And the sum of the larger and 4 times the smaller, 4 times the smaller, 4 times 5 is 20, and 20 plus 9 is 29. So it all works out. Whew. All right, that's all for now. Good luck with this one.